Hey, what's going on, everyone? We're at Team 11, and in this group we have Harris Deljanin, Devin Ursprung, Matthew Miraval, Mark Shkolniy, and Ivan Radonjic. Our advisor is Dr. Shanley, and we're creating a Resinous Cove tool for our stakeholder, Laticrete. So for our project, we were tasked with automating the process of applying the Spartacoat Cove material. Resinous coves are created by manually spreading and pressing the material against the corner where the floor meets the wall. This can be a laborious process for workers because you're constantly on your knees.
The dimensions of the finished product are shown on the right. This is a view of the cross-section of what the finished product needs to look like. 4 to 6 inches up, depending on what size they want to make it, and a 1-inch radius cove at the bottom to make a smooth transition between the wall and the floor. It takes a lot of skill to get these coves just right consistently, so for our design, we plan to automate the process.
So for our engineering constraints, our product will be lightweight and portable, no more than 20 pounds. The tank will have a 1.5 gallon capacity. The material temperature must be between 50 and 90 degrees Fahrenheit. The material will have a 60 to 7 minute working time. So after that, material starts to dry up. Ambient humidity must not exceed 90%. Machine must pay for itself over 3 jobs. There will be a reduction in variability in labor. The pump must be able to handle solids, and the product will be easy to use and clean.
One of the first problems we were tasked with is figuring out the viscosity of the Coves material. As you can see on the left, the way we did that was we bought a 5-ounce funnel and timed how long it took 4 ounces of water to flow through. After that, we measured how long it took the same volume of Cove material to pass through the funnel. Now, knowing the volumetric flow rates relative to water, we were able to calculate the viscosity of the Cove material to 221 centipoise. We also used Bernoulli's principle to design the best conditions for the material to flow through the machine properly.
This is the initial prototype design that we worked on throughout the semester, and our design plans to fully automate the mixing process as well as the delivery process of the resinous cove material to the cove mold, and there will be more on that later on. So our process starts in the mixing chamber, where we utilize a small electrical motor with a mixer attachment to mix our material for 4 to 5 minutes. Afterwards, it enters our pump, where it gets slightly pressurized and exits the system through a thin rectangular diffuser. But some future improvements that we need to focus on for next semester is trying to figure out how to make the tool as small as possible. So we need to take our mixing chamber, our pump, our cove mold tool, our battery, and try to configure all the components in the right way in order to make a nice sleek design.
Some of the main components that will be on the machine are the pump, battery, and PWM speed controller. The pump will be used to move the material through the machine. It is able to handle solids with a diameter up to 0.188 inches, and the grains in the Cove material are much smaller than that. The material will flow through the bronze section of the pump as seen on the top right. This lowers the chance of damages happening to the inside of the pump. The pump also weighs 7 pounds. The battery is used to provide power to the system and only weighing in at 5 pounds. The PWM speed controller will be used to modify the pump output. This part is vital for ensuring proper fluid flow through our machine.
So this is our cove mold tool and a little bit more on how it works. Basically, when the resinous cove material leaves the thin rectangular diffuser, it's going to be pumped straight into the cove mold tool inlet, which is rectangular, which goes into a smooth transition into the exact dimensions of how the Laticrete desires their coves to look like. Here are some of our preliminary tests on the cove mold tool. If I could just stop it right here, just to show you. The cove comes out perfectly every time, but the vertical section right here is way too small, and that needs to be made bigger. But other than that, the design of the tool is successful.
As for our senior design 2 plan, we have to figure out and finalize the dimensioning for all of our components. Once the parameters are finalized, we'll purchase the required materials needed and assemble a working prototype. As we do further testing of the prototype, we will refine any issues and problems along the way. The deadline given to us by Laticrete to have the working product is March 31st.